Okay. Madam, I give you as a host. Please start with your. Hello.
Yes, yes.
Yes, please, madam. Please continue on that.
Yes, thank you. So I was talking about this 5-number summary of data, that is also alternatively called measures of location. So those 5 numbers are actually mean, max, Q1, Q2, and Q3. Mean means minimum of the whole data, maximum. Q1 is the first quartile, it is called quartile, or it is also called lower quartile. Q2 is the middle quartile. Middle quartile. Your Q3 is upper quartile. Some of you might have seen this already in terms of box plot. If you have come across this box plot, you might have heard about this 5-number summary. For the data that you have, you can actually represent, you can visualize these values in a plot, and that is called the box plot. And that box plot actually explicitly shows you the locations in a way. Here, these ends are called the whiskers. And these whiskers reach up to the minimum and maximum of your data. Minimum, maximum. Here is your median, the middle value, median, which is also called the Q2, the middle quartile or the median. Here lies the lower quartile, that is Q1. Lower quartile, Q1. And here is your upper quartile. This is the location. Okay. These vertical lines are the locations. ऐसे करेगा तो मेरा बड़ा मुश्किल हो जाएगा बेटा. चल इधर बेटा. इसको तुम फिनिश कर दो बेटा. इसको बना दो. शेर नहीं डालना. शेर नहीं डालना को बनाओ. इसमें रखो. रखो. कहाँ गए? चल. फटाफट बना दो बेटा. एग प्लांट. शेर. चल. So here is your upper quartile, that is Q3. So we know how to look for the minimum. We know how to look for the maximum. We have already seen median. What about this lower quartile and the upper quartile? Lower quartile is actually the 25th percentile. And the upper quartile actually is your 75th percentile. Median, since it refers to the middle value, it obviously is your 50th percentile. So that is how you calculate. You will calculate minimum, you will calculate maximum, you will calculate the middle value, that is your median, and then the 25th percentile and the 75th percentile. So all these 5 values in a way almost summarizes your data. And if you understand these things properly and keep in mind, you will come across it once more when we will talk about outliers again. The box plots actually help you detect outliers in your data. Outliers, as I told you, it is those values in your data which looks quite different from all the other values. So how to actually find out those data? We humans can easily visualize, right? But how to make the program understand it? The box plot helps that way. It helps you locate, it helps you find, it helps you visualize as well. When we talk about this percentile, so I hope you have some idea about what percentile is. Percentile. Suppose you have this data. Let me show you with example. Suppose I have this 5, 7, 12, 15, 17, 19, 20. Suppose this is marks obtained by students of a class. Maximum marks being 20, and students have scored these marks. And you have these many students, of course. They have scored marks in this range and values. And suppose you have to make 5-number summary for this data. So min, max, median, you can easily make, right? Minimum, since that data is already sorted, I have already sorted it in ascending order. No? Min is 5, maximum you can see 20. What is median? 1, 2, 3, 4, 5, 6, 7, 8. The median is, how do I calculate median here? We have two middle values, right? 12 and 15. So we have to take the average of it to get the median value. So it will be 12 plus 15 by 2. 27 by 2. So whatever it is, what will be 30.5. I will talk about, so median is your 50th percentile, right? Meaning 50% of the data is below this. Can we say 50%? 50th percentile means what? 50% of the values are below this. You can check now. Are the 50% of the values below this? 13.5 is somewhere here, right? So 4 values below this, 4 upper. Anyway, median is supposed to represent the middle value. So this has to satisfy, right? Now, second is, now median is your Q2. You have already found. The thing that remains are Q1 and Q3. So Q1 is your 25th percentile and Q3 is your 75th percentile. How do you calculate percentiles means? How do you calculate percentile? Any idea? When I say 25 percentile means, this is the point in your data such that 25% of your values are below this, right? So how to calculate percentile means, the formula is percentile, number of values less than, you have to look for, divided by total number of values multiplied by 100. This is the formula for the percentile. So Q1 and Q3. Can anybody find Q1 and Q3 for this? Q1 is that value, that data below which 25% of your values appear. Can anybody find? Try it. I have given very simple data. I hope you are sitting with pen and paper, na? Just check.
Okay. Madam, Sabita madam.
Yes, sir.
हाँ. कंप्लीट हो गया क्या ये चल रहा है?
नहीं चल रहा है सर.
Okay, okay. Everyone, class is going on, right?
Yes, sir.
Okay. मोहन सर, आपका प्रेजेंटेशन कल होगा. Okay. Sabita madam, मोहन सर is here. मोहन सर
Yes, sir. Yes, sir.
ऑटोमोबाइल में है, ईवी में वो कुछ कर रहे हैं. कल उनका प्रेजेंटेशन है. हाँ मैडम. और
Yes. Good evening.
तो हम कुछ एक्सप्लोर करना चाहते हैं ईवी सेक्टर में. तो हमारा फोकस ये है कि हम ईवी में ऑटोमेशन लेके आए और इम्प्लीमेंट करना चाहते हैं. कुछ डिवाइस हो गया, नहीं तो कुछ नया चीजें ट्राई करना चाहते हैं. क्या क्या स्कोप है ईवी सेक्टर में, उसको हम एक्सप्लोर करना चाहते हैं. तो मैडम आपका भी थोड़ा सा टाइम ईवी सेक्टर में दीजिएगा, ऑटोमोबाइल सेक्टर में, कि हाउ वी हैव टू मॉडिफाइड ऑटोमेशन प्रोसेस स्टार्टिंग विद द ऑटोमोबाइल. ठीक है मैडम, प्लीज कंटिन्यू विथ योर थिंग्स.
ठीक है सर. Yes. Anybody?
Ma'am, what is small n, ma'am?
Yes, yes.
Ma'am, what is small n in the formula?
Hi, small n is the number of data which is less than that percentile value.
Okay, ma'am.
Try. I have given you the formula. Percentile is small n by capital N multiplied by 100. And percentile, I am already asking for 25th percentile. That means your percentile value is 25. Try. Anybody? Careful, beta. Center में beta. Anybody? You have to find the 25th percentile. You don't know about small n right now, right? But you have the idea of how many total data points you have. One, 2, 3, 4, 5, 6, 7, 8. Can you tell me now? From this, you will get the idea, no? At least a small n idea you will have. 25 times 8 divided by 100. How much is this? 8, 5, 44. Okay, it's a whole number. So it should be simpler, no? So n is 2. you have two values which is less than the percentile number. Okay. So that means your Q1 value should be 8. So that you have two values less than 8. So your QR is 8. Is it clear? The percentile relation is this one. Percentile is small n by capital N times 100. Statistical formula is this one. I'm asking for the 25th percentile. That means you have this relation, 25 equals small n over capital N, which is 8 times 100. Small n tells you that these many numbers are less than your percentile number, okay? About that quartile number. So since I am getting small n to be 2, that means from that value, you have two values which are less. That means your Q1 value has to be 8, so that you have two other values which are less than 8. That means 5 and 7. So 8 should be your 25th percentile. Okay. Can you tell me Q3? What is Q3 for us in this data? Q3. Can you be a little quick? Q3, Q3, Q3.
Ma'am, Q3 is 4.
Q3 is
4.
4. No. Q1, Q2, Q3 all will come from these data value only. Small n only tells you about that those many numbers are less than it. So are you getting small n to be 4? Is it?
It's
Q3,
19.
5?
It's
Q3, ma'am,
19.
it's coming 6.
I think 17, ma'am.
Small n is how much? Okay, small n is how much?
25, ma'am.
6, ma'am. Small n is 6.
The small n is
Small n is
75.
6. 1, 2, 3, 4, 5, 6. Okay, that means your Q3 value should be 19, right? Because you have got n equal to 6. That means you have 6 numbers less than 8. So count 1, 2, 3, 4, 5, 6. So if you must have 6 numbers less than 8, then your quartile should be 19, right? Because you have 6 numbers less than 19. So your Q3 value will be 19. So if you need to box plot this one, your box plot will look like I could have gone by Python programming, but having the idea what goes behind will be better, na? That's why I'm spending some time on it. Okay. So if you need to draw the box plot, how will you show? Your minimum is 5, your maximum is 20, your median is 13.5. This is your Q2, the 50th percentile. Your Q1 value, the lower quartile or the 25th percentile, it has two different names, is 8, and your upper quartile or the 75th percentile is 19. That is how the data is distributed in the list. Okay, you have value ranging from 5 to 20. The middle value is 13.5. There are two values. It shows that there are two values which are less than 8. Okay, there are 6 values which are less than 19. There are exactly half of the values which are less than 13.5. So this is your 5-number summary, also called measure of location. I will just quickly take you through one more measure, which is measure of shape. Some of you might have heard. Measure of shape. You have two measures of shape. One is one is kurtosis and the other is skewness and kurtosis. You can keep in mind these two terms, skewness and kurtosis. Now, skewness and kurtosis will tell you about how near or far your data is from the Gaussian. Okay, a Gaussian distribution is one of the most used data distribution. I hope you have some idea about how the Gaussian distribution looks like. The bell-shaped curve. This one. So when kurtosis value is 0, it indicates that the distribution of data exactly follows this bell shape. And if kurtosis is different than 0, either greater or less, then it shows the shape is either flat or picket this way. It is either more picket or more flattened compared to Gaussian. This is how it tells you about the shape. With respect to Gaussian, everything is with respect to Gaussian. Pink one is supposed to be your Gaussian distribution. So it basically tells you about how the data is distributed. And the value of skewness, it tells you about how heavy-tailed your data is. Meaning, is your data this way, right is skewed, or is your data left is skewed? So skewness will tell you about these. So at this moment, you can just keep in mind these two terms, kurtosis and skewness. So today we have gone through descriptive statistics. And we have looked at 4 different measures. Measure of central tendency, measure of dispersion, measure of location, and measure of shape. Central tendency, we went through mean, median, mode. For dispersion, we have seen variance, standard deviation, coefficient of variation, and z-score, right? And measure of shape, this kurtosis is skewness, and then the measure of location, that 5-number summary. So this almost summarizes all about the descriptive statistics. So next class, we will have a look at inferential statistics. Okay. Inferential statistics. I wished to show you the code as well. It took a time. Anyways, you can explore on your own. Look at NumPy package, the statistics package of Python, and try to calculate mean, median, mode, kurtosis, skewness, and all, whatever the measures we have read today. I think this pretty much wraps up everything for descriptive statistics. And that's it for today. Anybody wants to share anything? Wants to share, comment, ask? No. Yukta, Vikas, Shweta, Saurabh, Arjun, Devanshu.
No.
चलवाना बेटा. If there is no query, then we can wrap up the session. Okay, I had asked a couple of questions, no? Not a couple, only one question. You can find them out and let me know in the next class. Next class is tomorrow, right? So we can discuss tomorrow if you have something to say.
Okay, ma'am.